Hi, my name is Angchan, and I'm going to present the paper, Ultra, an Unbiased Learning to Rank Algorithm. Here's the outline of the presentation. First, we'll walk through the motivation, where I will talk about the learning to rank with user feedback and provide some important background knowledge. Then we'll discuss the Toolbox architecture, including all the layers and packages that are currently being supported. Later, we'll discuss the experiments run using Ultra and analyze the result. We'll then talk about the resource availability and how people can contribute to Ultra. Finally, we will talk about the conclusion and the future work. Learning to rank is a machine learning approach to train a model for ranking tasks. And as with any machine learning, we start out with a data set where we will train the ranking models. And once the model is converged, we'll deploy it onto production. The problem with learning to rank is that these datasets are usually very expensive and very time consuming to create. As a result, it is difficult for large-scale production. Hence why AI researchers have employed learning from user feedback or click data to train the model. Say the user wants to search something from a large document corpus, the learning to rank model will retrieve those documents and display them on the result page. The user will then click on the document that they deem to be most relevant and will collect the click log to improve our ranking model. While click data are user-centric and cheap, they usually suffer from bias. One of the bias are positional bias. Here, the user usually click on the document in the #1 position, making it the most clicks document, while the the document most relevant to the user query could be in position #3. If we use this click log to train our model, it will produce a rank list with document #1 as the most relevant document, while the correct rank list would be document #3 to be the most relevant document. Researchers have studied multiple algorithms to tackle this problem, and they are called unbiased learning to rank algorithms. These algorithms are broadly categorized into two groups, online learning to rank and offline learning to rank. In online learning to rank, we dynamically adjust how we present the ranking list to the user, so we can collect unbiased click signal to train our model with. Most algorithms from this group are from the bandit learning family, such as the popular dual bandit gradient descent. Offline learning to rank, on the other hand, reproduce a specialized learning algorithm in which when the ranking model learns with this learning algorithm from biased click data, it can still converge to normal ranking model trained with ground truth label. Most algorithms from this group come from the counterfactual learning family, such as inverse propensity weight. While there are many algorithms for unbiased learning to rank, they lack a unifying way to compare and benchmark them. Moreover, it can be very overwhelming for new researchers to study doing analytic work or extend their research on this field, because all of these algorithms are usually developed using different framework, data set, ranking models, and configuration. But existing works are not mature enough to try and benchmark all of this model, and are usually difficult to expand on if users want to add their own learning algorithm or model to it. As a result, we present Ultra Toolbox. The toolbox is developed using PyTorch, which is user-friendly. Moreover, because we only have one unifying pipeline, it is very simple to compare different learning algorithms and ranking models. Finally, with our API, it is easy for user to try out different configuration to train their model, and user can also add on their own learning algorithm or ranking model. Here's an overview of the Ultra pipeline. First, the raw data will be fed into the input layer to simulate clicks. This click will be used by the learning algorithm to train a ranking model. If the learning algorithm is an online learning algorithm, the ranking model will present its rank list to the input layers So the input layer can simulate the user click based on this ranking model, based on the ranking model rank list, and use that to continue improving the model training. And once the model converge, we will have an unbiased ranking models. The input layer, like I mentioned, are used to simulate user click based on ground truth label. User can choose 4 different techniques to simulate clicks: direct label feed, if the user want to use the ground truth label, click simulation feed for offline learning to rank, deterministic and stochastic online simulation feed for online learning to rank. The learning algorithms, we currently have 4 counterfactual learning algorithms, namely inverse propensity weight, regression EM, dual learning algorithm, and pairwise debiased. We also have 4 online learning algorithms: dual bandit gradient descent and its extension, the MSD and the NSGD. And finally, we also implement the PDGD. We currently implement 4 loss functions: the pairwise cross entropy loss, the sigmoid loss on list, the pairwise loss on list, and softmax loss. The ranking model, currently we only have 2 baseline models: a multi-layer perceptron that have 3 layers, hidden layers, and the linear regression. And finally, the util package. This package is mainly created to support contain different submodels to support other layers. For example, it contains different evaluation metrics. It have the propensity estimator for the IPW learning algorithm. It includes 3 click model to simulate click in the input layer. And it's also implemented team graph interleave for the deterministic and stochastic online simulation feed. For the experience, we performed 3 experiments with offline learning, online deterministic learning, online stochastic learning. We used the Yahoo Little dataset, and for the ranking model, we use a multi-layer perceptron with 3 hidden layers with size 512, 258, 126 respectively. We use NDCG top 10 as an evaluation metric. For a more detailed description on how the experiment is set up, you can check out our paper. As you can see from the result, it is pretty uniform with the result in other papers, where with offline learning to rank, we have the dual learning algorithm and the inverse propensity weight are the top 2 learning algorithm. For online deterministic and online stochastic, IPW is and IPW and DRA as a top performing algorithm. For online stochastic, the PDGD also performed pretty well as well. Resources, you can find the toolbox on GitHub at Ultra Community Ultra PyTorch, where you can clone or fork the repository. To contribute to the project, just feel free to create a pull request and add your own algorithm to it. So in conclusion, Ultra Toolbox is the code base that is used for experimenting, comparing, and researching learning to rank algorithms. It's a great way to benchmark these algorithms. The toolbox is flexible and extensible with different setting and tunable metrics and parameters for user to train their ranking model. And for future work, we plan to add more learning to rank algorithms as well as ranking model. We also want to optimize the toolbox to improve the execution speed so user have a better working time when using the toolbox. Thank you for coming.